wonderful 3-day weekend. This is the notes that I'm doing Tuesday and Wednesday, the 19th and the 20th. So, geometric mean. Geometric mean is kind of some background information to help us with the altitude formula. So this is a little bit of background information. So if you remember from when we did proportions, if I set up a proportion here, so if I set up a proportion, A over B equals C over D. So if I have this proportion, that proportion I could cross multiply, so I know AD multiplied together gives me BC. And we talked about this like 2 weeks ago. If I have a proportion, I can solve for any piece on this proportion by multiplying your diagonals. Now, geometric mean. Let's say I give you a problem that says find the geometric mean for 4 and 25. So if I'm trying to find the geometric mean for 4 and 25, I'm going to set up a proportion. 4 and 25 are kind of the far numbers. So they're going to go in these corners, 4 and 25. The geometric mean is what can I put in these two corners that would make this proportional. It's the proportional value. So I can put an X here and an X here because I don't know it. So anytime you have a geometric mean problem, you're going to end up with one of your diagonals being identical. And then the other two will be the other two numbers. So I can cross multiply this. X squared equals 4 times 25 is 100. So therefore, X equals 10. So what that means is if I put the 10 back into here, 4 over 10 is the same thing as 10 over 25. So 10 is the geometric mean between 4 and 25 because it's the number between them that gives you the same ratio. 4 over 10 is 2/5. 10 over 25 is 2/5. That's what it means to have a geometric mean. Now I've got 6 examples of these. And these kind of go, once you get kind of in the pattern of these aren't bad at all. So let's take a look at these. So this first one, I've got my 9 and my 4. My 9 and my 4 are going to go diagonal from each other in the proportion. Put X's in the other two corners. That's my setup. Multiply out those diagonals. X squared equals 36. X equals 6. So 9 over 6 is the same ratio as 6 over 4. That's what it means to have a geometric mean. It's the value between them that gives you the same ratio. So this guy, 14 over X, X over 16. That's how you're always going to set these up. 14 times 16 gives me 224. Now, sometimes these don't come out even, like this one. So when I take the square root of 224, X equals 14.97. Just round to the nearest hundredths, 2 numbers after. That one actually repeats. If you put 9/6 with a repeating bar, that's fine too. So that's the first two. The rest of them are pretty much going to follow the same way. Number 3, 9 and 30. So 9 over X, X over 30. That's my setup. X squared, 270. Take the square root of 270. And make sure you're square rooting, not cutting in half. Make sure you use that square root bar. Square root bar looks like that. So I get X equals 16.43. 16.43. And it should fall between 9 and 30. It should be between them. 25 over X, X over 49. So X squared equals 25 times 49. 1,225. Take the square root of 1,225. X equals 35. There's my value. So 35, 25 over 35 would reduce to 5/7. 35 over 49 would reduce to 5/7. So that gives me a proportional value. That's the geometric mean. 2 to go. Four and 120. So 4 over x, x over 120. Multiply out those diagonals. X squared equals 480. Again, this one isn't going to come out even. So take the square root of 480. X equals 21.91. 21.91. And then the last one, 9 over x. X over 18. There's my set. 9 times 18, 162. Square root, 162. X equals 12.73. So that's how to find the geometric mean. Now we're going to use the geometric mean for some triangles. This was just kind of background to help get us started. So the next problem. So what we have here, we've got this right triangle. Here's a right triangle that I split down in the middle to create 2 more right triangles. And it turns out that all 3 of these right triangles, the big one, the middle one, and the little one, are all similar. They're all similar right triangles. Now today we're only going to be focusing on this guy and this guy, these 2. The little guy and the medium guy. We're not looking at the big one yet. We're looking at the left side, the right side. And if you notice, this H gets used for both. Both triangles use this H. So if I look, X is a smaller leg compared to H, a bigger leg. So I can go X over H. And then over here, H I can compare to Y. H over Y. So this looks really familiar to what we did just a little bit ago, finding the geometric mean. Because H is the geometric mean between X and Y. Because H gets used for both triangles. It gets used for this side, gets used for this side. So X over H, H over Y. Now I'm going to real quick switch to a video. I'm not going to show you the whole video like I did in class, but I want to show you a picture, just so you can see why it lines up this way. So let me switch really quick just to one little picture of this video. So the one little picture of this video that I want to show you is this picture right here. This shows you why it lines up this way. This shows you. I had the big triangle here. They took this one and kind of flipped it and spun it and get it here. Same with this guy. They kind of flipped it and spun it to get it here. So this triangle and this triangle are the identical triangle. This one, this one. And if I look at these sides, this is the side, this is the side. So X compares to H, X over H, which is the same as bottom compared to bottom. That's why this ratio works, that proportion works. Because this side compares to this side, X over H. Yep. This side compares to this side, H over Y. That's what we're focusing on today. So like I said, I showed you about 4.5 minutes of this video for the actual class stuff, but I just wanted to kind of draw you into this one picture for this. So let me switch back to the notes real quick. Back to notes. Oh, I lost my thing. So back to my notes. And we'll clean up these extra circles. So my formula that I'm going to be using, remember H is used for both. So X over H equals H over Y. H is the geometric mean. Or I can think of it as left segment over middle. And middle is this one. It's also known as an altitude. Equals middle over right segment. And like I said, this is the one that gets used twice because the left side uses it, the right side uses it. That's my formula. That's my setup. So now there's 6 problems involving this. 6. And once you get the hang of this, this isn't too bad either. First 2. X is in the middle. I always like circling the one item I'm going to use twice. It gets used for here, it gets used for here. So 9 over X, X over 16. There's my setup. There's my picture. Multiply out your diagonals. X squared equals 12 times 16, 192. Whoops. 9 times 16, 144. Square root the 144, X equals 12. I get a 12 here. So I have one triangle that's a 9 by 12, another triangle that's a 12 by 16. 12 falls in between these two numbers. If you get something that's not between 9 and 16, something went wrong. So this guy, 4 over X, X gets used twice, X over 10. 4 over X, X over 10. X squared is 40. Take the square root of 40, X equals 6.32. So this is 6.32. So again, if it doesn't come out even, just round to the nearest tenth. Round it off. Next 2. Now I kind of turned it different, but this is still the one in the middle. I just turned it funny. So 5 over X, X over 12. X squared equals 60. Square root the 60. X equals 7.75. Now this one's a little bit different because I gave you the middle. So I'm still going to set it up the same way. This piece over 8, 8 over 15. So 8's the one I used twice this time because 8's the one in the middle. So 15x equals 64. So 64 divided by 15, 4.27. So x equals 4.27. So that's this number here. And yeah, 8, which is the one in the middle, is between 4.27 and 15. It's the geometric mean. That's the geometric mean. Last 2. Ten's in the middle. So x over 10, 10 over 7. That's your setup. 7x equals 100. 10 times 10, 100. 100 divided by 7. X equals 14.29. So this is a 14.29. And 10 is between 7 and 14.29. We're not looking at the average. It's not the same thing as an average. It's a geometric mean. It's the proportional average. Proportional. 15's in the middle. 15 over, whoops, scratch that for a second. 25 over 15. 15 over x. That's my setup. Multiply your diagonals. 25x equals 225. 225 divided by 25, I get 9. So x equals 9. So this guy is 9. So I have one triangle that's a 25 by 15 triangle. I have another triangle that's a 15 by 9. That's my setup. Now, Thursday and Friday, we're going to be looking at these again. But next time, we're going to be looking at the whole triangle compared to one of the two small ones. Today, we're just focusing on one side compared to the other side. That's what we focused on. So, remember, this is extra credit if you fill it out. Make sure you show some work, not just an answer. And adios.